right, you came back for round 2. First video seemed to work well and is already on YouTube, so let's try this again. We're going to be now focusing in on enzymes. What are they and how do they work? Enzymes are critical for life, so this stuff's kind of important, a little bit. All right, vocabulary is going to be some of it, and then reactions are going to be more of it. So, a catalyst is anything that speeds up a chemical reaction. Speeds up being the most important part of this definition. They make it easier to do the reaction. Okay? The way they do this, the how, is that catalysts lower the activation energy. Remember we said the activation energy is kind of like the cost of doing the reaction? With a catalyst, it's a lower cost, so it's going to be easier. And easier is always better. So guys, this little picture here, this is the normal. EA stands for activation energy. So if you have a high activation energy, it's really difficult to do the reaction. The enzyme knocks it down, it lowers it, and all of a sudden we're doing a whole bunch of reaction. It just became a lot easier. Now if you're watching in the notes, we just did 5 and 6. So make sure you get both of these written down, please. You know I'm going to ask. All right, moving on. Enzymes are biological catalysts. So enzymes speed up, that's the catalyst part, life reactions. All the reactions that happen in our cells, these are the guys responsible. Most enzymes are proteins. Memorize this. I guarantee you this was on the test. In fact, if I remember right, this is the first question of the test right here. If they're not proteins, they're RNA. You really don't need to know that. For our purposes, 99.9% proteins. Okay? All right, we're moving. Now this picture should look familiar if you've looked at your review. Some people have already asked me about it. And it shows how an enzyme works. You know I like pictures. So the blue line represents no enzyme or without enzyme. So it is the normal reaction. Now here's a question. We just finished one video. You tell me, is this reaction energy absorbing or is it energy releasing? How much do you remember? Do we go high to low or do we go low to high? That to me looks like high to low, which means the energy has left. You know the answer now. That's energy releasing. Bye-bye. Energy gone. Okay, back to enzymes though. So no enzyme, high activation energy, high cost. Oof, look at that big hill we got to go up. The red line though, the red line is with an enzyme. With an enzyme, there's still a slight activation energy, but it's much lower. Lower activation energy. Think without an enzyme, high cost. With an enzyme, it's on sale, low cost, and easier. All right? So that just kind of shows you how the enzyme affects the activation energy. It goes way down, makes the reaction a lot easier to do. Okay? So this is a question in your notes. I've been talking about it, so maybe you've already answered it. But what effect does an enzyme have on the required activation energy? It lowers the activation energy. Lowers the activation energy. It decreases from high to low. Okay? You with me so far? So next up, we're going to do just a tad bit of vocabulary. Again, wonderful words to know. The reactants, remember reactants are what goes into the reaction for an enzyme, are called its substrates. So in this example down here, the substrate would be this tiny red thing. It's going into the enzyme, and the enzyme's going to react with it somehow. I don't know what it's going to do, but it is going to change it. Notice this kind of like hole or indentation in the enzyme. It's the perfect spot for that substrate to fit. That means it is the active site. The active site of an enzyme is where the reaction happens, where the substrate binds, and where the magic occurs. Right? 2 good words to know. Now this picture, I have to admit, ladies and gentlemen, this is an awesome picture. This is, if you don't mind me saying, a test-worthy picture. Have I made myself clear? I like it a lot. All right. So on your notes, it says label the parts. We can do this. The funky blob-looking thing, that's got to be a protein. Proteins all have weird shapes. And if it's a protein, it means the blob is the enzyme, which means the weird hole in the enzyme where the substrates come in and where they change, that hole, that's your active site. That's the magic spot. Okay, and I kind of already labeled these a little bit. You see how they're going in? What goes in? Now this is an enzyme. Normally I'd say reactants, but since it's an enzyme, I'm going to say substrates. Okay. Now what comes out here, notice it's leaving. What comes out hasn't changed. That is still the product. So just instead of reactants, since it's an enzyme, we say substrates, but what is produced is still the product. No change there. And I think that's everything I want you to label. If you look, you can kind of see what happens. Our 2 substrates are bonded together. So apparently that's what this enzyme does. It's the glue that glues these 2 things together into one. It's a funky little enzyme. I like it a lot. Clear? Clear. Good. All right, here's the funky thing about enzymes. There's millions of them because each one is specific. Each enzyme controls one reaction and only one reaction. Okay? So we say the way they're so specific, the way they do this is this fitting the substrate fits in the active site, that hole again, just like a key fits in a lock. Okay? So every enzyme has a very specific active site shape. Different shape, different enzyme. Each shape fits one and only one key. Each active site fits one and only one substrate. So this means reactions are very, very specific. All right? Makes them unique, makes them really powerful. They have a lot of control in your body. All right, last topic I want to cover is what can affect an enzyme. These are going to be very similar. There's 2 things. I want you to learn both of them. Number 1, temperature. Okay. Every enzyme has an optimal temperature. Optimal means best. For most human enzymes, if you look, the optimal temperature here is about 37 degrees Celsius. That's approximately 98 degrees Fahrenheit. That is body temperature. So it makes sense. At human body temperature, our enzymes function the best. On the other hand, if you look over here, I have a heat-tolerant bacteria. This bacteria comes from a hot water geyser. Okay? So it functions best at about 75 degrees Celsius. I don't know what I was thinking there. 75 degrees Celsius, which, by the way, is just approximately 160 Fahrenheit. You did. I did. This little heat-tolerant bacteria loves it, and so does its enzymes. Okay? So temperature affects how well an enzyme functions. Likewise, the second one, pH. Temperature and pH. I know you've heard those before. Okay? So now take a look. Here are two enzymes. This one comes from the stomach. The pH of the stomach, acid or base. Oh, we've all heard of stomach acid. So acid means low numbers. This enzyme works really well in an acidic environment. Guess what? Most of your blood is right here at about 7.4, slightly basic. When this enzyme gets out into the blood, like if you have an ulcer, a hole in your stomach, it doesn't work. So this enzyme can't digest us. That's awesome. Now, on the other hand, in the blood, in the cell, we do much better in a basic. So this is all the non-stomach enzymes, the cell enzymes, the brain enzymes, the, muscle enzymes, much more basic because there's no acid in the brain or the stomach or the muscle. The brain, the cell, or the muscle. Now, I do want to point out one thing. If you look, when the activity decreases, what happens, and we can see it over here back, if I look back at temperature, we can see it here too. What happens if the temperature gets too high or we go into too basic or too acidic? Guys, when it stops working, you already know this. That's because the proteins, the enzymes of protein, it denatures. So it has denatured, it has unraveled, it has lost its shape. Okay? So that actually, I do believe, finishes us up. We've done all of the guided notes. Now you have 2.4 homework, please. It's that last page. Guess what? It's only one sheet. It's short. You're welcome. I want it on Monday. That would be very nice. Do not forget test review. Also, due Monday. Okay? You have all the information you need to do this. If you don't, or if you run into problems, you got my email, you've got my remind. I'm expecting you to reach out if you have any trouble. If I don't hear from you, then I hope you are having an awesome weekend. And one last thought. Go Panthers. Enjoy your first pep rally, gang. I will see you on Monday. Take care.